So, welcome to the overdubbed version, unfortunately. I finished this radio as far as we're going to be able to finish it today, the next day, and the sound is fine, but the sound isn't fine for the time I did yesterday. So we're on a Grandstand P2004 hand portable, which is quite a rugged looking thing. 4 crystal controlled channels, telescopic aerial, which is nearly intact. I did cover one of these before in 2014, my own one, and you'll see later on that my own one is in far better condition than this. These are sold as a 2-watt hand portable. We'll take that with a pinch of salt because I've never seen one do 2 watts. This is now the 3rd one I've seen. As ever, we won't be touching the battery compartment, that's entirely up to the customer. But as a courtesy, we'll clean those contacts. So the first thing we're going to have to do is take the telescopic aerial out. And straight away we can see the connecting wire, the white wire there, has snapped off, and that's due to corrosion. So you have to take the PTT bar off, but first of all you've got to take this metal cover off, and before that you've got to take the telescopic aerial out. We'll take that corroded cover off, and it looks even more corroded on the inside. Look at the state of those crystals. Every one of them is green with corrosion. I would think that this was on a ship at sea in a locker on deck for 20 years. That's how it looks to me. It's not been wet, but it's been in such a damp environment. And the corrosive one at that. You have to take the two screws out which hold the PTT bar on. Take the PTT bar off and make sure that you don't lose the spring or the little black button, which you can't yet see, which is actually the call tone. Strictly speaking, 2781 approved sets shouldn't have a call tone. But there you go. I think everybody can turn a blind eye to that. No, Mr. Tenga, you can't quite get it out. You've got to take the top off first. In fact, you only have to take 2 of those screws out and not all 4. Gives then the top enough tilt. And I know that because during the course of this repair, I've had that bored out about 20 times. This set will never work as it was intended to, but it will work, which is better than a static exhibit. So on these sets, the speaker is also the microphone. That's not an ideal way of doing it, but it does work quite reasonably on this, and it works very reasonably on the Midland 76805 Porta Pack, if that's the right number, where the little speaker microphone uses the speaker as the microphone. It is just so corroded. I am at this stage not knowing whether half the tracks are missing through corrosion. Unfortunately, that kind of jack is a 2.1mm and the pin doesn't go into it, so it's not actually making contact at all. Furthermore, that socket is so corroded, and it still is, that it isn't going to make contact. It's a 2.5mm centre pin, not 2.1. And be aware that it's centre negative, outer positive. It's the opposite way round for normal, so it's very easy to reverse polarity of the set, which goes without saying is 12 volts and not 13.8. So at this stage we've got no power. So connect it up to the battery connector at the top of the radio. But of course it's dead because the switch inside that power socket is so weak and corroded. So the best stage at this, best thing to do at this stage is to put isopropyl alcohol on and see if we can get rid of some of that corrosion, because it's eaten through the board. There's another parcel at the door. So I'll leave that to dry and go and take a lunch break. I think that's exactly what I'm going to do with this overdub, because it's absolutely 24 hours after I recorded this. Section 2. So I had a look on the internet and I found somebody selling one of these, or had sold one of these as a closed auction on eBay. And it looks to me like the circuit diagram originally came with it. Splayed out on the table was this radio and its packaging and its box and the instruction book and accessories. So this comprises about 1/12 of the photo. So I managed to extract that. It's not really readable down to the values, but at least it's better than nothing. And we can see the single conversion receiver and the crystal control, and generally it is a real help. I could really do with getting my hands on this and doing a decent scan. There's the transmit line starting at the arrow and working backwards. Output transistor, driver transistor, pre-driver, and the oscillator for the crystals. Receive side, again you've got a crystal oscillator, you've got the MC3357, and then you've got an audio IC which is an LM380, the 14-pin version. So that's a 1/4 watt one if I remember. Or is it 1 watt? I'd have to look that up. So just mentioning again that the speaker is the microphone. So initially I failed to realise this had an external aerial socket. I don't think I've seen one since 2014, so that's my excuse. So what I was going to do is to solder on a white or BNC plug the radio side of the loading coil, which I did. And then after I'd done the realignment, I realised there was actually an aerial socket. End of section 2. So we've got our adapter tree soldered onto the bottom of the board. As I say, I failed to notice that it's got an external aerial socket. Right, power it up, 12.5 volts. So using the little screwdriver to make it go into transmit, the transmit switch is a proper micro switch. The only observation I have is that it was drawing about 50 milliamps when we went into transmit instead of about 12 milliamps when it was in receive. Got no hiss from the speaker and you've got no actual transmit. So let's see whether it is transmitting just a few inches. So channel A is in fact channel 2. So that's clearly not getting anywhere. So disconnect from power and let's get these crystals out. We'll start with the transmit crystals, which are the ones with the trimmers in the center. That's so you can adjust the frequency spot on. Whereas the receive ones, it just receives what the crystal is. It's just as they drop or whatever with age, there's no way you can adjust them. Using the fiberglass brush, I'll clean the crystal legs. Also apply some Service-Sol to the socket. I tried to clean the leg of the crystal there with the pen instead of the fiberglass brush. So we'll turn now to the receive side, and this time I decided to take them all out. And what I found was bizarre is they were actually all in the wrong way round. So channel A, as I said, is channel 2, and channel D is in fact channel 39. So I found the receive crystals totally the opposite way around. So channel A was 39, channel D was channel 2. So as I was taking them out and then put them in the wrong sequence, so it would not have ever have transmitted and received from then on the same channel. Now we've got all the transmit ones to actually, I'm probably jumping ahead here, we've got all the transmit ones to actually oscillate. But as far as the receive one goes, channel 2 sometimes works, and channel 4 is the only one that works all the time. The other two channels in between, the crystals are just not doing anything. You can have crystals made, but you're looking at £35 each. I dare say that the crystals available for realistic Tandy sets for the 1002 model would actually fit and work. I recall they did, the sets came with channel 20 because they were a 2-channel set, and that left you a spare slot for another channel of your choice, and they offered 9, 14, 19 and 30, so you had 4 channels to choose from. So those crystals I'm convinced would work. But of course, tracking down the crystals for the UK set of frequencies for the Tandy sets is looking for a needle in a haystack. How many realistic 1002s have I had in here for service over the years? I would like to say 30. And I've never seen one with a second channel fitted. And I'll tell you what, when you do fit the second channel on the realistic 1002, you can't trim its frequency, you can only trim channel A. So your second channel can be off frequency. So here's the moment of truth when we connect it back to power, and this is the moment of disappointment. So here's the dilemma. Supposing no crystals worked in this radio, which is quite possible, I would have carried on and serviced the set using a borrowed pair of crystals out of a realistic 1002 and doing it on channel 20. And what does the customer do? So I've put the 2 crystals back. Certainly not working. We did build a digital crystal tester from an AliExpress kit. Can I find it? I've looked in all the boxes it should be in, but I can't find it. I'll have to build another one It'd be useful to know if those crystals oscillate at all. I did feel one of them did, but I don't think the frequency it was now doing was anywhere on the Citizens band. You never know, it may have picked up NASA spacesuits or something. Eating, and we're actually getting somewhere. We've got 1 watt now. When we started, before we started doing any tuning at all, I think we were greeted with 150 milliwatts. So put it into transmit, poking my screwdriver down the micro switch tab. Oh, 1.2 watts. I don't remember them actually doing 2 watts anyway. I think that's a bit of BS. I seem to recall, without looking back at the video, that when we actually did a field test on these, I think we got 1.5 miles. I don't think they actually work as well as the Midland. Was it 75750? The 4-channel crystal controlled handheld that Midland did, which was also 2 watts. Well, at least it only draws 230 milliamps. So at this point, it really is dreadful receive. What's there is so strangled. I'm hoping I show you the detector when we try and set the detector. I hope I show the oscilloscope. I thought I'd tuned it at this stage, but we had after this I decided the next day to actually recap the whole thing, not even charging for that, because I want the bloke to have a set that kind of works. So we've actually got some figures there which are, to be honest, better than some of the Cobra new sets you can buy. I think we ought to do a video and have every Cobra that ever was available legally in the UK and put them all out on a table, and then we'll get Mr. Chippy to drive away and we'll test every single one. And as they get newer, you'll notice they get worse and worse and worse. So the earth lead, which goes to the speaker, goes to that brown piece, which is actually a conductive copper pad, so that it acts like the case being a metal case, so the capacitance of your hand doesn't alter the tuning of the radio. Just cleaning the earphone socket there, that was successful. But that charge socket at the bottom, which I believe you can power it from as well, oh dear, it's so corroded. If I soldered a link onto that socket, the radio would work on batteries. But if I do that, it can never be plugged from an external source. So as I overdub this, and having finished the video as far as the service work goes, because the next section has got original sound. I'm going to have a look and see if we can actually get one of those sockets, because what's the bloke going to do otherwise? I think at this point we've disappeared off to the other test bench behind me to check the deviation, and then we discovered it didn't have any deviation. I'll also have explained that the receive crystals are 455 kHz lower in frequency than the transmit crystals. This is absolutely normal to take the IF, the intermediate frequency, into consideration. So if you're supposing you're on channel 1, which is 27.60125, your transmit crystal will indeed be 27.60125. But on receive, it'll be 0.455 less than that. After taking this radio out of its chassis apart about 15 times, I got to be quite good at it. Because this has had to be overdubbed, you haven't seen much of the tune-up procedure, so I'll do a photograph of the innards and colour it in like I do, and I'll show that on the air test. Okay, so I've actually spent a lot of time recapping this. It's the next day, because it turned back on again. I can't say channel 1's reliable, but I'm on channel D or 4, whatever it is, so that seems to be reliable. Let's put picture in picture on, and we'll just have a final look at the cyanide meter, because recapping it I've had to retune it. If we look at the oscilloscope now, put the big signal on, turn the volume up, and you see we've now got a sine wave instead of a dreadful square. Actually sounds like a radio now. So let's go over to the cyanide meter. Now we've got 12 dB. So we're going to fill this in again, and it's 0.88 microvolts. For 7.5, and for 20 it's now 2.4. Transmit not going to be affected, still doing 1 watt. What I have restored by changing the capacitors in it, I've got my monitor receiver on here, there's a call tone, so you got that. So that's about all we can do. This DC socket is knackered. I just don't know what the customer's going to do about it, because I can't kind of get onto Beware and get one, can I? Don't know whether Mr. Chippy's going to take that apart. But then of course that incurs another fee. We've got a lot of duff capacitors. Let's see whether channel 1 actually works. It's a bit iffy. So channel 1 is supposed to be 27.61125. Channel A, shall I say. Let's go on to the frequency counter. 27. Well, that's the right frequency. Another go at cleaning it. I think it's intermittent. No. Nothing there at the moment. Go back to channel D. So what we've got 2798125. Well, that's near enough, but as you can hear, it's receiving fine. So transmit. We have got transmit. Just turn the tone off. Where's my handheld gone? It's there. Testing 1 2, testing 1 2 3 4 5. There's your call tone. So we're all set up, but what can you do with something which is in such a state? Spent a good 4 hours cleaning it with isopropyl alcohol, getting things to work. Got a new wire in for the aerial. We'll leave the video at this point. I'll have to ask Mr. Chippy whether he wants to dismantle that socket. It may not be dismantleable and kind of strengthen up the contacts. It's certainly not something I would tackle. I'm not a parts mender like he sometimes does. So there we go. You have the Grandstand P2004, which looks like it's been at sea for 20 years and is reliably working on one channel and sometimes works on two. Thanks for watching.